f of x equals x to the 2/3, 2 minus x. X to the 2/3, this is the cube root of x squared, and multiply by 2 minus x. The domain, nothing to worry about 2 minus x factor, but the cube root x squared, the cube root, no restriction as well. So you can put anything inside of the radical, the index 3. So the domain is the set of all real numbers again for this case. Okay, when you have the radical rational, you have to think about the restriction before you move on, because some number, as you find for the critical value, you have to ignore it because it's not part of the domain. But for this case, you can do it. Question? Anyone? All right. So first of all, find the derivative. The first derivative, you can do the product rule or expand them all out and find term by term, either one. Okay. For this case, it might be more convenient to expand them all out as 2 times x to the 2/3 minus x to the 2/3 times x. But this one, you have to think about the appropriate property to simplify the term. All right, the first one, the way it is, and the second term, this is x to the power 2/3 times x to the first. So combine 1 and 2/3 power to get 5 over 3. Okay, to get 5 over 3. So then we get minus x to the 5 over 3. I'm going to write in the cleaner version. So our f of x is in another form as 2 times x to the 2/3 minus x to the 5 over 3. So to find f prime, use the power rule. 2 over 3 times x to the negative 1 over 3 minus 5 over 3 times x to the power 2 over 3. Just be careful. And this becomes 4 over 3 times 1 over the cube root of x. Negative power is the reciprocal of the positive power. Minus 5 over 3 x to the 2/3. I should keep it as the power 1/3 here as we simplify it later. And organize the expression. I'm going to have 1/3 here as 4 over x to the 1/3 minus 5 times x to the 2/3. The power as a rational is the one that might lead you to the wrong process, or your algebra is, can be messed up with this. So I'm going to rewrite it as one fraction form with the common denominator x to the power 1/3. Then the numerator becomes 4 minus 5. And this gonna be from x to the power 2/3 times x to the power 1/3, which is what? Which is x to the first, or just x. Okay, from making the same denominator. This is algebra. Okay, so multiply top bottom by x to the 1/3, x to the 1/3. That's how I get this fraction. Why I put in this fraction? Because the next step, we're gonna find the critical number. Critical number is from f prime 0 or f prime undefined. This is the easy and less complicated way to help you find the critical value without getting lost. And why would I say that? Because from f prime, let's adjust this a little bit. Now from my f prime x equals 1 over 3 times 4 minus 5x divided by x to the 1/3. To find the critical number, we have two cases. The case that f prime equals 0 or f prime is undefined. Okay, it's undefined. Why I say this is the less complicated way? Because the f prime equals 0 is from the numerator equals 0, which is 4 minus 5x. The f prime undefined denominator cannot be 0. That's the case that make it undivided, right? So we just take the numerator expression equals 0 for one case. Denominator equals 0 is another case. And then we solve for x. So x equals 4 over 5, one of them, and x equals 0 as another one of them. So now we have two critical numbers. Okay? And then, let me see. For x equals 4 over 5 and x equals 0, we just put it on the real number line. And this is the real number line for the f prime. I'm going to copy that term again. 1 over 3, 4 minus 5x over x to the 1/3, which is the cube root. And then as I analyze as the previous problem, f prime 1/3, this one are already positive term. So we just consider the sign of the 4 minus 5x as one factor divided by the factor of the cube root of the x. Okay, and I locate the two critical numbers, put 0, put 4 over 5, and any number greater than 4 over 5, greater than 4 over 5, for example, the value 1. Okay, that's an easy number. The value 1 on the right side of 4 over 5. If you put 1 in here, it's going to make this factor to be negative sign. Okay, negative sign. This is kind of the margin here. Break it down. So the number greater than 4 over 5 going to make this factor to be negative. And the left side of the 4 over 5, which is lower number than 4 over 5, for example, like negative or even like 2 over 5. 2 over 5 going to make this positive. The negative number even make it positive. Okay. Similar way to the cube root. The cube root depends on the sign of the radicand, or the one that you put underneath the cube root. The, the reference point is a 0, right? Because the cube root of 0 is 0. The number greater than 0 gonna make this factor to be positive. The lower number than 0 gonna make the cube root to be negative. So then the sign of the f prime, which is the sign of negative divided by positive, I get negative inside here, positive here, negative here. Okay, f prime negative, the graph decreasing, f prime positive, the graph increasing. Okay, so then what we have so far is we got the interval of increase decrease. So to summarize here, the next slide. So for the interval of increase, that means the sign of the f prime positive gonna be the interval 0, 4 over 5, 0, 4 over 5, and the interval of decrease gonna be between, negative infinity, 0, and 4 over 5, 4 over 5, infinity. Okay, so this from the first derivative. And also from the first derivative here, you can use the first derivative test to verify whether any local max, local min occurs. Okay, for the first interval here, the graph decreasing. Second interval, the graph increasing. The right one, the graph decreasing. So we have local minimum occurs at 0. Local max occur at 4 over 5. Okay, so we summarize here. Okay, so this one by the first derivative test.